Welcome to
the ultimate container change.
This is a one-of-a-kind quiz where we're going to test your knowledge about OCI, containers, the whole ecosystem.
Yeah.
So take out your phones, put your internet connection back on, and without further ado, my co-host, Aurélie.
Hi, so I'm Aurélie Vache. I'm a developer advocate at OVHcloud on cloud-native, Kubernetes, and on infrastructure and as code. And you?
And I'm Sherine. I've done a lot of different things around the tech world. Today, I'm at Red Hat, and I work on the OpenShift stack. So, are you ready?
Yeah.
So, if you scan the QR code, you're going to have a white page with a blue banner. Don't worry, your names will be asked after. Give correct answers, be very fast,
Yeah.
and top 3 contestants will win some prizes, among which the Kubernetes in a visual way by Aurélie. So all of your answers will be tested through some live demos as well. So here we go. First question. So here's when you'll get asked for your name.
Yes. Cool.
Come on.
A lot of people. It's cool, it's cool. Okay.
Come on, let's give it a minute.
Oh, yeah, 11. Oh.
All
They are
right.
fast. They are quite fast.
OK, don't worry. The QR code will still keep coming. Keep them coming. Yeah. First question. Ready?
Ready? Go.
OCI, what is it? Optimal Container Initiative, Open Container Image, Open Container Initiative, or Open Cloud Native Initiative?
What do you think?
Easy one.
Tic-tac. Easy? Yeah, easy one.
And correct answer is
yeah.
Open Container Initiative.
Congratulations.
Good job. So what's...
Oh, videos is first. Oh, yeah.
Anonymous. Great.
We don't know.
Open Container Initiative, for those who don't know, is an open governance around containers. It standardizes 3 things: the image structure, the manifest that will describe the image. It standardizes the runtime, so whatever your container engine is going to use, Docker, Podman, Cryo, all use the specification. And then finally, the distribution specification, so the way that you use the APIs to talk to your registries, pull, push images, and so on. OK? Next question.
Next. Question number 2. Are you ready? As usual. So, OCI and Docker are the same things? Is it true or is it false?
Come on, easy one.
Tic-tac. For the moment, it's easy. So, little users. True or false? The easy one. Yeah.
Yeah.
You're right, it's false. Videos is still on the top. Go on.
Nice.
So, in 2015, Docker has donated its image format and its runtime to OCI. Since Docker and OCI evolve separately with a few differences, but the tools like Docker, Podman, Skopeo, Crane do their best to hide these little differences.
Question 3. Take out.
And now it will be a
bit harder.
Yeah.
Is the Docker image format identical to OCI's? Well, sure. OCI and Docker v2 are the same thing. Or OCI is a fork of v1. OCI and Docker v2 are slightly different or completely different. I know we're playing on words.
No.
Right?
Oh.
OK.
OK.
So
they know.
Most of you are right. OCI and Docker v2 are slightly different. I'm sorry for the subtle little differences in the response. So here's why. We pulled an image, the same image, once in Docker format and another time in the OCI format. What I'm showing you here is the OCI manifest. As you can see, it has a media type, OCI image manifest. It has a config with a certain media type as well, and a digest. So this is a very specific, like a signature of what this contains. Layer as well has this type of digest. If I were to diff between the manifest of the OCI image and the same one in Docker v2 format, you'll see that the only difference is media type, which means that the contents of the layers is exactly the same. So you're going to say, but why did OCI do that? What's the end game here? Well, basically, opening this up is what led to us being able to put inside containers things that are something other than runnable containers. So this is how, for example, Helm modified their CLI in order to allow you to push a Helm chart to the registry. This way you can consume it from the registry the same way as you do your containers. And if you look at the Helm manifest for this image, you'll see that Helm created their own media type, both for the config layer and for the main layer. And since it's 2025, and all of us are data scientists, right?
AI check?
Yes. So Aurélie and I created a really very small
a tiny one
model. And with Oras, we're going to push this to my local registry here, and we're creating our own artifact type as well for the occasion. And that's it. Next question.
I'll go back to a slide. You don't see it. So question number 4. What happens when I push an image to a registry? My image is pushed as is. My image is compressed during the push, or each registry has its own compression algorithm. Tick-tack.
Bit hard.
So, oh, okay. Oh, c'est cool. So, yes, my image is compressed during the push, and we'll see it. So, oh, this codeboard is different, cool. So, it can be surprising, but the image size locally and on a registry are not the same. And when we execute the Docker push command, just before the upload, the client compresses the layer on the fly. And we will see it and live on a demo. Up. So first, we log in on an OVHcloud managed private registry. We will build an image with the Docker build command. OK, we build, is in cache. It's quick.
Thank you, Cache.
And now we will see the image, the size of the image. So locally, it's 22 megabytes. OK. And now we will push the image on the private registry. And we will check on the private registry and also on the Docker Hub. We'll see if there will be a difference of the size. OK.
Does the registry has anything to do with it?
So if I check on Docker Hub, for example, the size is 10 megabytes. So it's compressed. And on Arbor, if I check if, OK, I click in, and it's the same image size. So same size on Arbor and on Docker Hub. And we can do another one. We have some tips. We can change the compression mode during the push with Podman. We can say, I don't want to use gzip algorithm, but if I have a very big AI LLM image. It's better to use standard compression algorithm. So I can do it with Podman, and also I can do it with Docker. And as you can see, the command is not the same one. That's because I had all the useful flags. I can change the algorithm, I can change the level, and I can say I want to, for the compression, I want to use ZSTD also for the base image. And done for me. Up.
Okay, next one.
Next one. Are you ready? Hi.
Next one.
Go, go, go.
When you're deleting something from the image using run rm -r, for example, /helm, does the image size decrease, stay the same, is almost the same, or does it increase? I know, it's playing on words again.
No,
But
never.
you'll see.
Never, never, never. Oh.
Okay.
Very
Are you curious to know what is the correct answer?
Yeah.
It stays almost the same.
Almost.
I'll try to explain
Continuation.
why. Nice.
Yeah.
Okay, so when we're adding the run inside the Docker file, we're not removing any layers. We're not touching any layers. We're just adding one extra one with a file, single file, 0 bytes. That's why we're saying almost the same. This file is WH, which means whiteout. And it's only the container runtime that's going to interpret this file in order to remove the folder at runtime. So here's the demo. So first thing, I have a small folder. It contains a Helm chart and a container file. Container file is exactly your Docker file, but OCI naming. Okay, so you see in step 4, I'm running the RM, build it. And next, using Podman, we're saving it to the local folder. So here, let's take a look at this local folder. This is what an image in Docker v2 format looks like. So if we were to loop on the layers here and to check if there are any files called Helm in there, we'll see that we still have our Helm folder here. This layer didn't change. And here is our file. This file is going to be interpreted at runtime. And that's it. That's why.
Question number 6. Ready? Images built locally run everywhere. Obviously. Build once, deploy anywhere. Or it depends, or no. Tac. So, yeah. Oh, yes.
Good.
It depends. Good catch. Oh, it's a little.
Nice work, Vinny.
So, by default, an image is built for the machine platform and the architecture. For example, if you have a Mac M1, 2, 3, 11, and you build an image, it will be for ARM64. And if you execute a Docker run command on AMD64, it will not work. So the solution can be to create a multi-arch image and see it on live on demo. So we create a builder to create our images with Docker buildx create with a name and use flag. And we will inspect this builder with Docker buildx inspect comment. So as you can see, we have a lot of platform to use. So we can create images for AMD64 and ARM64. Okay? So let's build it, our image, for these two architecture with Docker Bricks, and we will push it directly on the registry. So it's okay. Layers are pushing. Okay, it's finished. And we will display the manifest with another tool, Crane Manifest. So as you can see, we have our ARM64, and AMD64 architecture. It's okay for us. And we can check on the registry. So we can go to the Docker Hub, for example. Look, and we can check our new tag, multi. Well, yes. So what I like on this Docker Hub is that it's very visual to see that this tag is for these two architecture, and that's cool.
Yes.
Next.
Next question.
Number 7.
What are open source formats for software bill of material? You have two right answers. SPDX, CycloneDX, TyphoonDX, SIFT.
What do you think?
And
okay.
not so bad.
Yeah,
not so bad.
It's cool.
Okay, so SPDX and CycloneDX are open source. SIFT is not open source. TyphoonDX is a complete imaginative thing.
Oh!
Great.
Yeah.
Vinny, come on. So, SBOMs, it's an inventory of everything that composes your container image from the top to the bottom, or bottom to top. We need to know all the vulnerabilities, all the licenses, everything. So, SPDX or CycloneDX, well, you can choose. So SPDX is pushed by the Linux Foundation. It has an ISO 5962 certification. It's very verbose. CycloneDX is more into automation, into vulnerability scanning. It's pushed by OWASP. Well, OCI doesn't choose for you. Up to you to choose between the two. And most of the tools that we use today support both. So here's a quick demo where we're going to look only at the SPDX format, but CycloneDX works exactly the same. So here, for example, with Trivi, we are going to generate an SPDX in JSON format for the image we built earlier. And because JSON is very hard to read, at least I find it so, BOM is a good tool for you to view your SBOM. So here's what an SBOM looks like. Here you see that the Gopher API has a few relationships to other packages, right? BOM and Trivi are not the only ones that allow you to create SBOMs. You can use Docker Scout, for example, to generate an SBOM. You can also use Podman with the ---- SBOM scanner command, and BOM as well. Now, fun fact, if you're running the three tools on the same image, you will not get the same SBOM. Okay, so some of them are very verbose, like Docker Scout. Others are really super small, super summary, like BOM. Now, Today, most of the registries are starting to allow you to push the SBOM alongside your image. This is what Oras, for example, allows you to do when you do an Oras attach. So that's /tmp/result.json that we created with 3v-up. We're going to be able to push it to the registry with the artifact type harbor SBOM v1, because the registry that we're using is a harbor registry. So that it recognizes that this is an SBOM. And basically that's it. So this way you can consume your SBOM right next to your image. You can also discover that SBOM through Oras Discover, like this. And that's it for me.
And the last?
Yes, we are at the final question.
The last
Vinny,
question.
come on. You can still win the book.
We can win. So go fast and good. So, with cosine, I repeat, with cosine, when I sign an image, signature is an extra layer added in the image, a new image tag, or a copy of the image. The last, go. So, drum roll. Oh, so you think it's an extra layer added in the image?
Ah, you can't. If you add a layer to the image
In
changes.
fact, it's an image tag with cosine, and we will see. Just before, congratulations, Martin, G. Liblos, and X-Red. Please do a screen capture of your phone and go
Come see us
after
doing your swag.
So, cosine is a tool that will allow you to sign an image without modifying it. And the signature is a new image tag in the format SSSSHA256, the digest.sig. And the final demo? Oh. So, first, we generate a key pair with cosine generate key pair comment. As we are on a live demo, I will don't type a password, but if you are on function, please, please, add it, enter it. So we skip it. We have a private key, public key, and as it's recommending to sign an image by the digest, we will retrieve it with docker inspect command, and we retrieve only the repo digest field. Okay, we have it, tiny one.
Yes.
It's tiny. So now we can sign our OCI artifact with cosine sign command. And as we are at KubeCon, we can add useful information, a little annotation with conf equals KubeCon London. We add the key and the digest. I don't have any password, sorry. So this command do two things. As you can see, the signature is put on our registry, and also a T-log, a transparency log, have been created, generated, and stored on a record server. Okay, so let's check if the image has been signed with cosine verify command. Okay. A long time. So, okay, it's good. I have the signature and all the key pair, all the key value are on an optional field. Okay, it's good. Let's check it on our private registry. Doof, doof. Okay. So I will go back in my Manage Arbor. As you can see, it was in red. And now the image has a signature, and so it's there, signature, and also an album. Yeah. So we can have some information like the tag. And we can also retrieve this tag with a CLI with cosine triangulate. It's not a well-known command. And we can inspect the manifest with crane manifest command. Hop. So, as you can see, we have some information. It's a signature by cosine, and signature is there. And we have also a body payload with a lot of information. A little bonus track?
Yes.
Yeah.
Do you remember what tools we used to do the demos?
Yeah.
Let's see if you remember. Anybody?
What tools?
No?
Docker,
Okay.
crane, Podman?
Yeah.
Okay.
So here's a quick takeaway for you. These are the tools that we used. There are many, many others. We put a superpower next to each one so that you can remember that more easily. And on this slide, we don't have the two main ones that I'm sure all of you know and use on a daily basis if you're a container developer.
Obviously, yeah.
So there's a lot of things in the ecosystem. Just choose the tools that do the thing that you need.
The ecosystem, yeah.
The ecosystem is huge. There's a lot of things that are moving still. So that's it for us. We hope that you learned something with us today. And thanks you so much for attending.
Thank you.